Hey there guys, Matthew and George here with freeccnetworkbook.com, and in this video I'll be discussing Lab 1-1, which is identifying router components and accessories. First off, let me set your expectations of this video. I'm not going to be doing any configuration demonstrations. I'm just going to be sitting back, relaxing, and talking about the history of Cisco routers, as well as the architecture and different types of WAN Interface Cards, different types of network modules, RAM, flash, cabling, so on and so forth. So with that being said, let's go ahead and get started. In the early 1990s, Cisco released the 2500 series routers, which were a fixed configuration platform, and because of that, oftentimes that was their biggest downfall. For example, if you had a branch office that was using token ring, and you wanted to migrate that token ring network to an Ethernet, you would actually have to replace the 2500 series router altogether, and that way, because of that, it would get really costly. So Cisco attempted to modularize their portfolio using the 2524 series platform, and this particular model here I have a picture of here on my desktop. It is a 2500 series that kind of looks like the 2600s that has the modules in them, but these modules are a little bit larger. I have a better picture of the module here. This module here is the T1 module. It has an integrated DSU. Keep in mind, back in the day when the 2500s were very popular, oftentimes they used the serialized DB60 connections for T1s, and that would require an external DSU, which either the company would have to lease from the ISP or have to purchase. And with the integrated DSUs for the T1 cards, this actually was a big cost saver, and that is why it's most dominant today. You don't have to rely on a second piece of hardware in order to have connectivity to an ISP. Now, in 1996, Cisco released the 3600 series platforms, which were completely modular. Because of that, a lot of businesses felt a big sigh of relief due to investment protection, because now the 3600 series WIC cards were compatible with the 1600 series branch office routers. So you could basically just pull a WIC out of a 1600 and slap it in a network module for a 3600 and it will work just fine. And this WIC architecture was actually evolved forward with the 2600 series, which was released in March of 1998. However, going back to the 3600s, there was one key feature of the 3600s that I personally liked, and many engineers as well, which was the ability to remove the flash. These platforms had a PCMCIe flash card slot on the front of the platform where the console and auxiliary ports were at. And this was a very handy feature to use when you updated iOS or you was in charge of disaster recovery. So that feature was removed in 2600s. However, Cisco added a feature similar to that in the 3700 series platforms, which was released around the same time as the 2600s. The 3700 series, which includes the 3725 and 3745, used a compact flash removable memory. This compact flash is commonly used with digital cameras, and it was actually the foundation for the future development of all platforms, even including the integrated services routers, which include the 1800 series, 2800, and 3800 series routers that you'll see quite a bit today. Also, compact flash is used on several different devices and appliances for Cisco, including the ASAs, as well as different line cards for a 6500 or 4500, different services cards for 6500, such as the wireless Wisdom or the ASDM. I'm not the ASDM, but the firewall services module. Man, I got way too many acronyms up there in my head. It's hard to memorize all these things when you know so many of them. In May of 2002, Cisco released the 2600 series multi-service platform routers, which was basically an update for the 2600s. XM simply stands for extended model. The XMs often they offered a significant performance increase, which was due to the upgrade of the bus. The 2600 series platforms used an EDO bus, whereas the 2600 XMs used a 125 MHz synchronous RAM bus. The 2600 XMs also had 16 megs of flash integrated onto the system board, which will allow you to update the update the platform to a total of 48 megs of flash. That is if you use a 32 meg, 3.3 volt SIM. Initially, the 2600 series supported 128 megs of RAM. However, later on, when Cisco released the 1228R boot ROM, the 2600 XMs supported 256 megs of RAM, utilizing 228 meg, 100 pin, 125 megahertz DIMMs. The 2600 series platforms have 200 pin slots for memory, but as I said earlier, the original 2600 series uses EDO, so therefore the memory out of a 2600 XM is not compatible with a 2600 vice versa. Now, initially there was an issue with the 256 meg upgrade for the 2600 XMs, which was a software limitation at the time. During 12.3, if you had the 12.2.8R boot ROM and you had 256 megs of RAM, the 12.2.8R boot ROM would actually decompress the image from flash into high memory, so therefore you would actually have more memory available to the iOS kernel. Keep in mind the typical size of a decompressed 2600 image for the extended model platforms were about 50 to 60 megs, so therefore you was actually freeing up 50 to 60 megs of memory for the iOS kernel. However, this issue was resolved using 12.3T. I believe it was 12.3T15. I may be wrong. I'm not really for sure. I'm just thinking that's what it is at the top of my head. However, this issue was completely remedified. What is that word I'm looking for? Remediated. There we go. Remediated in 12.4. So therefore, 12.4 no longer has the iOS kernel limitation, and you can utilize the full 256 megs of RAM. The 2691s were also released around the same time period as the 2600 XMs. Basically, the 2691s was a baby brother to the 3725s, and if you put them side by side, you will be able to tell there is a very similar physical appearance. Basically, you know, the 2691 and the 3725 had 3 WIC slots as well as 2 fast Ethernet ports built in, a compact flash slot for removable flash memory, and a network module. However, the 3725 does have a larger slot on the top of the platform, which allows for the installation of a wide network module Ethernet switch, which supports up to 36 fast Ethernet switch ports. Moving on, the ISRs were released in 2004, which included the 1800, the 2800, and 3800 series platforms. The ISRs introduced the new HWIC, the high-speed WAN Interface Card architecture, which that architecture supported a 400 megabit aggregate bandwidth among all the slots on a specific platform. Meaning, for example, you have a 2811, which has 4 HWIC slots. Among those 4 HWIC slots, you have a 400 megabit limit among all of them, so therefore they are shared. Aggregate meaning all together, so to speak. With that being said, the WIC architecture previously, which was HWIC's predecessor, commonly found on 2600 XMs, 2600s, 3600s, anything older than the ISRs would use an 8 megabit shared PCI bus. And with that being 8 megabits, there was actually an issue with the WIC 2T, which is commonly a question found today on technical forums. I actually see this question asked quite a bit. When people utilize the WIC 2T, you can have a single port on a 2600 using the WIC 2T operated at 8 megs per second, or you can have 2 of the ports on the WIC 2T, which are a smart serial interface WAN interface card operated at 4 megabits per second. However, if you use 2 WIC 2Ts on a 2600, or a network module such as the network module 1FE, 2W, 1FE, 1 token ring, 2W, so on and so forth. The limitation also applied to several of the network modules, but if you use 2 of those WICs, you would actually have to only utilize each smart serial interface to use 2 megabits per second. So therefore, you could not tax out the smart serial interfaces each at 8 megabits per second because of the WIC architecture was only a shared 8 megabits bus. So keep that in mind if you ever build out a branch office and you're wanting to use used hardware. You might want to spec out the performance regarding the WIC architecture. If you're going to need a WAN interface that is going to support faster than 8 megabits per second, you're going to have to go with the ISRs. Or use a fast Ethernet port. The 2800 series, excluding the 2801, has 4 HWIC slots. As I said, they support 400 megas of aggregate bandwidth among the chassis. Also, the ISRs the 2811 and higher supported the new network module enhanced architecture, which operated at a shared 1.2 gigabits bus across the entire platform, whereas the predecessor, the network module itself, which is commonly found on the 3600 series and the 2600 series, including both the original and the extended models, were only capable of operating at 600 megabits per second across the entire platform. So hopefully that's a pretty nice little bit of history and architecture discussion there for you to understand. It's nice to actually understand some of the history and architecture regarding Cisco platforms, as it will definitely help you in the future when you need to build out branch offices, or you need to scope out a scenario, you know, for a future build out, and you have specific requirements as performance goes. So excuse me. On this page I also compiled a nice little Cisco Matrix, which includes all the different platforms, all of them except the ISR G2s. I've not gotten around to adding that to this page yet, however it is on the list to do. This little matrix here, or chart, whatever you want to call it, is very handy when you want to build a lab, especially for the 2500 series chart here. As you can see, I have all the 2500 series routers here listed, as well as the max RAM and flash they support, and what types of interfaces they have. Like I was talking about earlier, the 2500 series has a fixed configuration, and the scenario I gave earlier, let's say if the branch office had a single token ring network, commonly that would have been used with a 2502. And if you wanted to update that network to Ethernet, you would have had to move to a 2501, which has the AUI interface, which you can break out to 10BASE-T Ethernet using an AUI transceiver. The AUI interface also supported different types of transceivers, such as a 10BASE-FL, also a coaxial interface, as well as the 10BASE-T. However, there was a platform that supported both Ethernet and token ring, but because of the way the fixed configuration was, you got what you pay for. Commonly, if you purchased a specific platform that had multiple different types of interfaces on it, you would have had to pay more during that time period. So, like I said, that was the biggest downfall of the 2500s, was the fixed configuration. However, they are a great platform even today with the lab routers, as you can actually run IP version 6, as well as OSPF v3 and RIP next generation, which is basically RIP for IP version 6. You can do all that if you use 12.2 T15 rebuilt 17, which is a very nice image. Be sure to get that image with the IP Plus feature set to utilize all those features. The 2523 here is commonly used, as well as the 2522. Both of these platforms were commonly used, or still commonly used, as a frame relay switch. However, if you're building a lab, it may be cheaper actually to buy a 2610 and buy a network module 8 asynchronous serial interface, which is basically the network module 8 AS. Commonly that might be cheaper. Sometimes I see on eBay some of these resellers are selling the 2522s for like $225, and you can actually buy a 2610 and a network module 8 AS, which will work just fine in the 2600s for about $75. And you can configure that platform to operate just as well, you know. So, the 1600 series I actually included here on the Matrix is basically, to me, I think they are a paperweight or a door stopper, but a lot of people say that they are a nice router to use as an endpoint for testing. For example, you can just disable IP routing on these platforms and enable or configure an IP address on the interface, and use them specifically as like a host machine, so that way you can actually do ping tests and trace routes and so on and so forth. That's about the only good use I can find of these. Since the memory is quite limited, the features are also going to be quite limited as well. The 3600 series, which is another popular router for lab environments, the 3620 makes good frame relay switches as an alternative to the 2610. However, due to the memory limitation of the 3620, they cannot run 12.4. So if you're going to use a 3600 series as a lab router, I would definitely suggest using the 3640 and use 128 megs of RAM, 32 megs of flash, so that way you can actually use 12.4, the iOS release 12.4. Keep in mind when you use the 3600 series, since they are completely modular by nature, you will have to purchase a network module, one E2W or one FE2W or whatever you require per your lab requirements. Because by a basic unit, the 3600 series, all they have is network module slots and an auxiliary and console port. That's it. And not very much you can do with those ports. I did include some cute little notes down here regarding the platforms. For example, different types of interfaces, different types of memory, the processor speed, so on and so forth. Keep in mind when you measure a router performance, it is not measured by processor speed. However, processor speed is taken into consideration when you're doing process-based switching, which is utilized when you use what am I looking for? I know it's up there somewhere. Come on, where are you at? Man, I hate it when I get a brain fart. Oh my gosh. Policy-based routing. There we go, policy-based routing. I knew it was in there somewhere, I just couldn't find it at the moment. It was on the tip of my tongue. But yeah, when you use policy-based routing, that type of routing is process-based, so therefore the faster processor you have, actually the faster the process-based switching will perform. However, general performance is measured using CEF, Cisco Express Forwarding, and that is commonly the performance specification for Cisco platforms. For example, the 3620 can perform at 20 to 40,000 packets per second, also known as kPPS. You should familiarize yourself with that term. Also, when you get with the larger platforms like the 7600 series routers or the 6500 series Catalyst switches, those platforms will be measured in MPPS, which is millions of packets per second. So, moving on here, the 2600 series chart here is probably one of the most valuable charts here on the table, the page, whatever you want to call it. And it talks about the maximum flash for each of the platforms as well as the performance and the different types of slots. The 2600 series actually introduced the new AIM slot, which is not in the 3600s, and they are not in the 2500s as well. I don't think they're in the 3600s. I'm not really sure about that. I haven't really looked inside of a 3600 for a while. I may be wrong about that. Let me check. Let's go to Google Images here. I wonder if I can find an inside picture of a 3640 real fast. There we go. Courtesy of Images, yeah, so there's no AIM slot in the 3600s, but if you go to a 2600 and you view the inside of a 2600, you'll see this little white slot right here. That is also known as an Advanced Integrations Module slot. And with those slots, you can actually utilize different types of IP services processors, such as a Cisco Unity Express module or an ATM encapsulation module, as well as a cryptographic engine that processes SSL or IPsec encryption traffic. So that's a nice little addition. The AIM slots were also available on all the 2600XM platforms as well as the 2691, and they're not on the 1700 series. However, they are in the 3700 series. But the 1700 series is another really good platform to use as a lab router, especially the 30. I'll get it out in a second. The 1760. The 1760, if you're going into voice over IP, you will definitely see the 1760 quite a bit, as this is probably the cheapest, most affordable voice over IP router you'll be able to get, and it's actually very feature packed. It has the ability to support VIC cards if you use DSPs, which are digital signal processor cards. Little bitty, they look like memory sticks. You can install those on the motherboard on the 1760, and the 1760 will support the VIC 2FXS which is a foreign exchange station, which allows you to connect a fax machine or a telephone, analog telephone, to the router, or a VIC2FXO, which is a foreign exchange office, which allows you to connect your router to a telephone company jack, such as PSTN, PTSN, whatever. And that way you can actually supply dial tone to your router from a telephone company such as Verizon, Bell South, AT&T, whoever. The 3700 series, which is considered the mid-range router of the millennium, so to speak, around the year 2000, was a replacement for the 3660, and it maxed out at 256 meg of RAM, 128 megs of flash, had a fairly high performance rate for the time, and it has AIM slots, like I was talking about. And there is one limitation for the 3700 series, I believe, which regards the Cisco Unity Express AIM module. The Cisco Unity Express AIM module cannot be installed in one of the AIM slots on the 3700 series, if I remember correctly. I may be wrong. I'm thinking it's the 3700 series. You might want to double check, though, if you plan on going the voice route. So there should be a sticker on the AIM module, so I would definitely adhere to those warning stickers. You don't want to fry anything. So 3700 series has 3 WIC modules. 3 WIC slots, not module slots, and 2 fast Ethernet. The 1800 series, which was the Cisco's attempt to move back to fixed configuration routers, such as the 2500 series. Now you're probably wondering why Cisco did this, and there's a very good reason for it, and it's because of price. You know, if you've been in the Cisco field long enough to know how much Cisco equipment costs, then you'll definitely know that Cisco is probably one of the most expensive network manufacturers out there for networking equipment. Basically, there is an old saying that I like to stick by, is you definitely get what you pay for. So if you go with a cheaper manufacturer, don't expect to have all the cool features that Cisco is going to offer for those different manufacturers. The 1841 is actually the only 1800 series platform that has 2 H-WIC slots. All the other 1800s are fixed configuration. Like I was saying, the major difference is the price regarding the 1800 series. It is actually cheaper to buy a 1801 that has an ADSL interface built into the platform and have a single SmartNet contract on that platform versus buying an 1841 as well as an H-WIC 1 ADSL and having 2 SmartNet contracts on those 2 different pieces of equipment. Obviously that's going to raise the TCO, which is total cost of ownership, for the 1841 solution. So therefore companies would oftentimes go the fixed configuration route. And as you can notice here, there's very small difference in performance. So there's quite a few footnotes here regarding the 1800 series, which talks about different types of supported features, different types of supported different types of supported interfaces, and so on and so forth. So the 2800 series, which is probably one of the most popular routers that you'll see in production today, which refreshed the 2600 series. The 2811 is very popular among branch routers, and the 2811 and the 2801 oftentimes replace the 2600s and 2600 XMs. So there is some footnotes down here as well. For example, the 2801 does not support the H-WIC 1 gigabit Ethernet module, which is basically an H-WIC that has an SFP slot on it, which allows you to install an SFP to support SX or SX or fiber or LX fiber or so on and so forth. 3800 series, which is the high performance, high end ISRs for the first generation ISRs. There is one cool thing about the 3845 I included here, which has a footnote. The 3845 is actually the first platform to utilize a dual core processor, which is a dual core BCM 1250 series, dual core 650 megahertz processor. Performance specs of 3825 operates at 350,000 packets per second, 3845 500,000. So the 3845 and 3825 can handle multiple DS3s fairly easy. So with all that being said, I think I've discussed quite a deal on this page. You should definitely check out the chart before building a lab if you haven't already built a lab. It's nice to know the max RAM and flash of different types of platforms. Also, if you're going to build a lab, I would definitely recommend that when you buy stuff used, try to buy the equipment that has max RAM and flash. If you don't, for example, if you buy a 2600 off eBay and it has 32 megs of RAM and 8 megs of flash, it's actually going to cost you more to buy an additional 32 meg RAM 100-pin stick of EDO and a 16 meg flash stick than it would be just to buy a 2600 that was already maxed out. So keep that in mind when buying used equipment. Also, when buying used equipment, especially off eBay, you can commonly find a lot of good deals. Whereas, for example, you can buy a 2600 that has like a network module for AS already in it, and oftentimes you will pay cheaper for those deals than you will when you buy a 2600 and buy the network module separate. So always keep your eyes open and make sure you check out the entire market before you purchase a used Cisco platform. So, well, with all that being said, I hope all this information is educational for you. And if you have any questions, feel free to post a question down here at the bottom of the page, and I will answer them. The questions can be posted anonymously if you like. Just be sure to include your email address. If the question is a little bit more specific to your scenario, I will respond via email. However, if I respond here, all my responses will be in blue. So if you see a response from me and it's not in blue, then it is not coming from me. So, with that being said, I hope this video has been educational for you, and I'd like to thank you for viewing.